So welcome. This is the last presentation, so thank you all for being here. Hopefully it will be something useful. So my name is Kostis. I'm working as a developer advocate at Octopus Deploy. It's a software deployment company and also has a GitOps product with the acquisition of Codefresh, which was my previous company, if you know this name. And I'm also part of the Argo team, focusing mainly on Argo CD and Argo rollouts. And today we're going to talk about this problem. You have a nice green/blue planet. It's your Terraform investment. It works just fine. And then Kubernetes appears, and Argo CD appears, and a huge meteor is hitting your nice planet, and you're wondering, oh, what is happening now? Can these two work together, or is this a catastrophe? So that's the main topic of the presentation. I'm going to talk about the problem, and then I'm going to show not one, not two, not three, but actually 4 solutions on how these can work together, how you can use both tools in the most effective way. And we also have a teaser trailer about the future. So first, let's talk about the problem. If you're not familiar with Terraform, you should be. It's a great tool. It allows you to define your infrastructure in a declarative manner in an HCL file. And for the purposes of this presentation, when I'm saying Terraform, if you use OpenTofu, that's fine. I won't, mention both names. It works exactly the same way. So this is what you have right now in your company. You have a set of infrastructure objects like databases, virtual machines, gateway, storage, and you have already created your Terraform files, and everything works just fine. Okay, there is no problem. But then Kubernetes appears, and your company or your manager says, oh, we need to migrate to Kubernetes, or at least start some new workloads with Kubernetes. And Kubernetes is a huge investment, so you need to reevaluate your Terraform investment. And now you have a choice. You can do many things. The most simple way is to just say, okay, I will just deal with Terraform as another piece of infrastructure. That's it. So I will not change anything. I will just use the providers of the cloud provider I'm using and will create Kubernetes cluster with Terraform as I'm doing with everything else. Now, this is one, let's say, approach, which you can see on the top left, to not change anything and just say Kubernetes is another piece of infrastructure. Or you can say something else. Okay, Kubernetes is something new, something exciting, and we know that it will take over the workloads. So instead of saying this is just another piece of infra, let's do a separation and say we will keep Terraform for infrastructure, and for Kubernetes, we will do something different. And in our case, it will be Argo CD. So this is the second choice at the bottom. And then later, we will also see the bleeding edge, which is the plot twist of this presentation, the reversal of roles. But let's stay on number 2. You have 2 different words, on the left Terraform and on the right Kubernetes. And you say, okay, what I'm going to do with Kubernetes, I'm going to follow GitOps, and I'm going to use Argo CD. Because Argo CD is great, we all love Argo CD. It's the best GitOps tool ever. But now you have a problem. You have some pieces of configuration that your applications need, and you need to pass those pieces of configuration to Argo CD into your applications, and these values come from Terraform. So you need to run Terraform first, and then take those values and make them known to Argo CD. That's the problem that we are going to talk about today, and it's a very popular question. I see this problem all the time. I'm following the CNCF Slack for most Argo projects, and you can see the same question again and again. I need something with Argo CD, and this something is created from Terraform. What do I do? How do I pass it over? These are actually some screenshots from Reddit DevOps, I think, or Kubernetes. People are asking the exact same question. I have already Terraform. I want to use Argo CD. How do I use these two together? So let's see the solutions. Number 1, just use DNS. It's the most simple solution. So here we have an example where I have an application, and this application needs a database, and the developers come to you and say, oh, we need the name of the database. Like, where should we connect our application? And what you want to do is to run Terraform first, create the application somewhere, maybe it's an RDS database, and then give that name to the application developer so they can connect. That's the problem you have to solve, and you need a way to pass this information. So how do we solve this problem with DNS? And of course, I'm using database as an example, but it's the same question for everything. Usually it has some kind of networking, like maybe it's an ingress, somebody mentioned an ingress before, or a load balancer name, or a name of Kubernetes cluster, anything that is network related. So the solution is to not actually pass anything, but just use DNS as it was designed. So the whole point of using DNS is to give somebody a human readable name, and then behind the scenes, you can create some sort of infrastructure that gets binded to this name. So instead of waiting for the application and saying, where is my database, you agree with the application in advance and say your database is always at db.prod.aking.com or .example. That's the server that you should use. So the developers just go and use this name, and then behind the scenes, you run Terraform, and you create a database and all the DNS records that make this name that you just gave to developers a reality. So there is nothing to pass. You just have an agreement between the developers and your Terraform files on where this database is. And here I want to say some things regarding applications, because almost always I see developers or operators and they have an application that is not created in the correct way. So they are trying to solve a problem with Terraform or Argo CD, while in reality, this problem is the database. So even when you adopt Kubernetes, you should make sure that you talk with the developers and say, look, now that we are going on the cloud, you need to create your applications correctly. So as a minimum, look at the 12-factor config page and understand how an application should fetch configuration. Okay, it shouldn't be hard-coded. Also, you should make sure that your application is generic. It doesn't know that it's running in Kubernetes, or it doesn't expect something for Kubernetes or Terraform, and minimize all your external dependencies. So in the ideal world, an ideal application knows absolutely nothing about Terraform or Kubernetes. It just starts and says, oh, I need a database. My database is at my DB, and that's my DNS name. I need a Redis installation. This is at my cache. I need another service from the same company, and this is at my PG. That's how the application should behave in the ideal way, and this is what you should tell the developers to do. And then behind the scenes, this host name can be anything. It doesn't really matter to the developers. So they start the application, and the application just works, and this might be something created by Terraform, or maybe it's a database created in the same cluster, or maybe it's a hard-coded name. It doesn't really matter. The developers don't really care about this. They just need the host name. So this is the agreement that you should have with the developers. And I'm mentioning the developers again and again because sometimes I think operators or SREs or sysadmins, they are trying to solve problems in the wrong, let's say, scope. So if you have a problem with your application, you should talk with the developers and explain the problem instead of saying, oh, the application cannot change, or I don't want to deal with the developers, and let's try to solve this problem with Terraform or Argo CD. No, go back and talk with the developers, make them understand what is the issue, and they will help you. Okay, if they know the problem, they will help you as well. But sometimes they don't know what you want. So here is another bad example. There is an application that is moving to Kubernetes, and as soon as it starts up, it goes on its own and contacts Vault in order to get secrets, or Consul in order to get configurations, or even the Kubernetes API to get some stuff. So now this application is your problem, and you say, okay, but where is my Vault server? How do I pass this information to the application? Or what kind of access should I give to the Kubernetes API? And the answer is that you don't. You tell your developers to design the application in a generic way. The application shouldn't know that it's using Kubernetes. It should just do the standard thing of getting configuration from files, okay? Or environment variables. Files are a bit better. So the application starts up, and then it's up to you to do all the magic things behind the scenes to create the application files that the application needs. But as far as the application is concerned, it is just reading files. And maybe these files have the database name or the load balancer name or the ingress name or whatever else the application needs. That's how you should design your application. So what are the advantages and the disadvantages with this approach? First of all, it's super simple. You bypass completely the problem of transferring stuff. You don't transfer anything from Terraform to Argo CD. You just have an agreement. You say, this is the database name, and everything should agree on this database name. It works great for developers because they don't have to deal with anything else. You just say, hey, start your application, and everything will be ready for you. So they are happy. For developers, this is perfect. But you also have some limitations. First of all, you have no single source of truth. And remember, we're at GitOpsCon. Like, you have configuration in two different places. You have your configuration of the database in Terraform. You have your configuration in the application configuration. And these two should match. If you want to do a change, then you need to notify two parties, so you lose this advantage. It only works in some cases. This pattern cannot work for everything. It's great, for host names and other networking stuff, but it doesn't work in other cases, and also it doesn't work for secrets. Like, you cannot, agree on secrets in advance. And if your application is not created correctly, you need to talk to the developers, and they might have to do some changes. So it has advantages and disadvantages. So that was approach number 1. Now let's go to approach number 2, and remember, we're at GitOpsCon, so it should involve Git. So let's say that Argo CD is a great GitOps tool. Let's do what Argo CD is designed for. Let's pass all the information it needs via Git. So we have Terraform that it will do its own thing with your infrastructure, and if there are some values that need to be sent to Argo CD, we will commit them in Git, and then Argo CD will pick them up. And how do we do this? Terraform has providers for GitHub and GitLab that essentially allow you either to create a new GitHub repository or even create a new file. So you can use Terraform to commit files in Git. Okay, if you didn't know this, Terraform can do that. So I can create with Terraform whatever I need, maybe my database, and then for some specific files, in the case of Kubernetes, a good example might be a config map. I can create this file with Terraform on the fly and then commit it to Git using the GitHub provider that Terraform has. And then from that point onwards, I pass everything to Argo CD, and Argo CD does whatever it does every time. It just syncs from file from Gits, and it doesn't really care or know where these files came from. In our case, they were committed from Terraform, but as far as Argo CD is concerned, it's just another file in Git. So here I have an example. Let's say my application for some reason needs to use a configuration that I need to pass via Terraform. So in this example, it's a service account, and there is an ID there, and this information is known only to Terraform. I can run Terraform apply, create whatever resources need to be created, and then use the GitHub provider to commit this service account into Git. So then Argo CD takes over, it goes to the Git repo as it has in its application setting, and sync this file like any other file. For Argo CD, it doesn't make any difference. So again, this has advantages and disadvantages. First of all, it's very flexible. You can pass any kind of configuration. The example was with a service account, but you can create a config map or any other file. Now you have a single source of truth. It's all in Terraform. So if you run Terraform apply again, ideally this file that you create in Git will be committed again with a new value, and Argo CD will just sync it. And as far as Argo CD is concerned, it doesn't know anything in the world. It just does what it does all the time. It just syncs files. So it's a very good way to separate completely these two products if you want to have this separation. But there are some disadvantages. First of all, you have more moving parts. Now you're using your Git repository for yet another reason, and you need to know that Terraform has access to your Git repository, and it can commit you to your Git repository. And depending on your security requirements, maybe this is a problem. You still cannot do anything for secrets. You cannot really commit secrets to Git. We know that this is a bad practice. So again, this works for some of the cases. And also you might have some performance or security issues, because now you have Terraform automation that is committing to Git in addition to other Git commits that maybe your developers are doing. Okay, approach number 3, inject Kubernetes resources. Apart from the GitHub and GitLab provider, Terraform also has a Kubernetes provider and a Helm provider, and you can use Terraform to create Kubernetes resources directly in the cluster, and also Helm releases. This is another solution that I see all the time. So here, essentially, you fool Argo CD, you give a Git repo to Argo CD that has only some of the information that the application needs. So in this example, the deployment and the service are in Git, and Argo CD takes them over. But you go behind the scenes with the Kubernetes provider of Terraform, and you inject a config map in the same cluster. And this is not controlled by Argo CD. So now you have created an application that is coming from two different places. And the application works. Like, if the application needs those 3 components, it runs just fine. But as you can imagine, there are several limitations. First of all, the advantage is that you can create anything you want, like the Kubernetes provider of Terraform is super powerful. You can create any resource that you want. And if you want, you could also pass directly secrets. I'm not saying that you should do that, but this is a choice. You can create with a provider a secret resource in the cluster. But on the other hand, you have limitations. First of all, Argo CD now controls only part of the application, so it doesn't really know what is happening. You're not following GitOps anymore because some parts of the application are in Git and some parts of the application are not in Git. And you also need to handle dependencies. Like as soon as Argo CD runs, if the resource is needed, you need to make sure that Terraform has already created this. And for simple applications, maybe this can be done. But if you have complex applications, essentially you are abusing Terraform as a way to deploy applications. So last choice, GitHub Bridge. This is a project specific to Argo CD. It's open source. You can find it in GitHub. And this is the image that they have in the front page. And personally, I don't like this image. I think it's super complex. So I'm going to completely skip it and instead explain my own image. So the way this works is that you create Terraform to create your Kubernetes clusters that will house your Argo CD applications. And then in the cluster metadata, when you connect a cluster to Argo CD, you can also put some optional metadata. You add whatever information you want to pass to Argo CD. So maybe it's some kind of networking configuration, maybe it's some kind of ID, maybe something else. You store it in cluster metadata. And then with Argo CD, you can fetch this information via application sets and get this information from cluster labels. If you are not familiar with application sets, you should be. It's a great tool for Argo CD. Essentially, they allow you to distribute applications on different clusters. And specifically for this presentation, we're interested in the cluster generator that has the capability to fetch the clusters that are connected in Argo CD. And in the default configuration, you just get the clusters and that's it. But if you're using GitHub Bridge, you can also fetch the labels that are on this cluster. So here I have an example where, again, I want a service account. My Argo CD application needs a service account, and the details of the service account need to be created with Terraform. So Terraform runs first, creates the cluster, stores the information as a label in the cluster, and then Argo CD takes over and takes those values and puts them in its own application. So it's a pretty long way on how the values reach the cluster. The good thing about GitHub Bridge is that it has several templates. So if you want to do something that many other people are doing, you can find pre-made configurations right away. And this is a great starting point because it's easier to take something and edit it instead of starting from scratch. So again, advantages and disadvantages. This is very flexible. You can pass any configuration that you want. GitHub Bridge has several templates that you can use right away. But also you have several limitations. First of all, it requires application sets. And personally, I like application sets, but some people don't like it. It's not really GitOps because now your information is split into two places. It's on Git, like the Git repository, but it's also on cluster labels in Argo CD. Last time I checked, it worked only with Helm. So if you're using Customize, I'm not exactly certain how it will work. And then this still doesn't work for secrets. Like you cannot really store secrets in clusters. I mean, you can, but it's not a really good idea. So now I know that you're thinking, I have explained about 4 solutions and almost all of them look as hacks. Are they hacks? Yes, they are hacks. Let's see what you should do instead. So remember the original choice, and here is the plot twist of the presentation. Instead of keeping separate Argo CD and Kubernetes, you can do something more drastic and say, look, Kubernetes is so important that I'm going to use Kubernetes to manage my infrastructure. And I will reverse completely the roles of applications and infrastructure. And this is another common question that I see all the time. This is from the Slack channel of Argo CD, and people say, I love Argo CD and I want to deploy infrastructure with Argo CD. And you probably know what I'm going to mention here. Check crossplane. Okay, this presentation is not about crossplane. I'm not going to go into crossplane, but you should know at the very least what crossplane is doing, because essentially it allows you to describe in a Kubernetes manifest infrastructure. Okay, so forget about the standard manifest deployments, pods, and services. Here I have a manifest that describes an S3 bucket, and I could also have a manifest that has a virtual machine, and I could also have a manifest for a VM or a database. I think this was one of the questions in the first presentation, how you deal with GitOps and infrastructure, and crossplane is one answer. And as I said, I'm not going to talk about crossplane. Here is also another favorite project of mine. This is Atlas. It has nothing to do with MongoDB Atlas. It's Atlas Go, and it allows you to describe in Kubernetes manifest database migrations. Okay, think about this. I have Kubernetes manifest that describe database migrations. So imagine the future where I'm using Crossplane to create my database, okay, maybe an RDS database, my Redis installation, my VM, my load balancer, and then I apply those manifests with Argo CD, and then I'm using Atlas to bring my database to the expected state, so apply all the SQL files with the correct schema, and now the database is ready to be used. So by the time Argo CD takes over and deploys the application, everything is there, okay? Everything is ready. Everything has been done in the GitOps way using just Argo CD. So conclusion. These are essentially the 4 choices that we have seen together on how to use Terraform and Argo CD. With green, I have the advantages. With orange, I have the disadvantages. And you can see no solution is perfect. It depends, on your risk and your acceptance. So if, let's say, GitOps is super interesting to you and you want to follow the GitOps principles, then you can use the Git provider with all the advantages and disadvantages. If you want to get something quick and get started quickly, you can use GitHub Bridge. If you want to pass secrets or have maximum capabilities for everything, you can inject resources. If you want something super quick for a quick application that only uses database, you can use DNS. So these are the choices of marrying Argo CD and Terraform together. But please go and look at crossplane.io. I'm not saying, evaluate it or start using it, but at the very least understand what it does, because almost all the times after some time where you try these workarounds, the proper answer is crossplane. Like people come to me and they say, how do I use Argo CD and Terraform together? And I try from these 4 approaches first, but after some questions I realize that they have a more complex scenario, and crossplane is the answer. And that's it. I hope this was useful. Thank you very much. Scott, your cue.
Yeah, it took me a sec. I thought I didn't know you were going to end right at that moment. Hello, thank you. Thank you very much, Kostis, and hi, Sysmit. I think there are a couple of. Let's see. Yes, there are a few questions. Excellent presentation, Kostis. Really awesome. Let's see.
There is a question, which other resources we can inject? So if you go to the documentation of the Terraform provider for Kubernetes, you can see there in the documentation all the resources. I think it's all of the standard Kubernetes resources. Like if you want, a config map or a deployment, you can do it. With the Helm provider, you even have, let's say, more power, because you can take any Helm chart out there, either public or private, and install it with Terraform. So by the time Argo CD takes over, it's already there. This is also a very popular way of how you install Argo CD itself on the cluster. Like you create with Terraform the cluster, and then you use the Helm provider of Terraform to install Argo CD, and then you point Argo CD to a Git repo, and Argo CD takes over. So this is how you do bootstrapping in the proper way. With Terraform, you just install Argo CD and nothing else, and then all the workloads are for Argo CD. So check the documentation of the Helm providers and the Kubernetes provider of Terraform. This was the answer to Mario's seminario.
Yes, thank you. And there was also a question in the chat a little bit asking anyone using Crow as an orchestrator. And
how does it perform versus Crossplane?
And how does it perform versus Crossplane? Yeah, exactly.
So my limited experience with Crow is only from the great presentation that Victor has created from DevOps Toolkit. I haven't evaluated Crow myself, but you can watch this presentation. He is answering the exact same question, just an asterisk. Victor is working for Crossplane. This is also a good disclaimer for me. I'm not working for Crossplane. I have no, affiliation with Abound. I simply love the project, and I think it's a great answer on how, you create infrastructure with Argo CD. Actually, most of the choices I explained, I think the first 3 could, in theory, apply to Flux as well. Anyway, so if you watch the video, his conclusion was that Crow right now offers a subset of what Crossplane can do. So if you want something really simple, maybe Crow is a good solution. But if you want something advanced, Crossplane is, let's say, the maximum flexibility solution.
Well, I think those are all the questions. Yes, I believe those are all the questions. So, Kostis, thanks very much again, and thanks to all the other presenters, and all of you as attendees. Thanks to Linux Foundation staff and the other Open GitOps events team, and the people who helped to organize this. So really appreciate it. I want to just close out for a moment by sharing with the few of you who may not know how to keep up with this community. Clearly, you know how to keep up with the community on some level because you are at this event. But in case someone linked it to you and you don't necessarily have all of the resources to continue to get various updates or even know how to get involved, the very best way to do this would be to go to the the easy entry point to remember anyway is to go to opengitops.dev, which is the website for the Open GitOps project. There you can find the link to the GitHub organization, where there are several different repos. One, the documents repo that includes the GitOps the published official GitOps principles and glossary, and other documents that may come. One is the project document that gives information about how all the things that I might mention here, how to get into the monthly meeting, the now once monthly meetings, how the different teams work for Open GitOps if you are interested in contributing or potentially even becoming more involved. We have different teams that work on different areas. For example, the events team here, but there are other people that work on, for example, content for investigating one concept around GitOps at a time for blog posts, or even just to work on a white paper, such as how GitOps relates to environmental sustainability and or secrets, or security, or other things like that. So anyway, those are the easy places to do that. I'll paste the link in here. We'll keep this open just for a little bit so folks can download pieces of the chat that they want and the links. And just as a final note, that these recordings will be uploaded to the event page that you registered for to be able to get into this event. So as soon as the Linux Foundation, the recording is finished, LF staff members will post that to YouTube under the Linux Foundation channel, I believe. And in any case, that will be linked to the event page. So once again, thank you, and looking forward to seeing you next time.
Thank you, everybody.